Somewhere in the multiverse, there exists a world almost exactly like ours. Same curiosity. Same ambition. Same irresistible urge to automate everything. With one small difference. In this world, the silicon transistor was never invented. Not delayed. Not replaced. Just never happened. And yet, they still built artificial intelligence. This is the story of how humanity decided that paper was a perfectly reasonable foundation for machine intelligence. These were their data centers. Not server racks. Not blinking LEDs. But warehouses. Measured in square miles. Each warehouse was filled with punch cards. Stacks upon stacks of them. Every card represented information. Language. Math. History. Sometimes, the answer to a single question. Memory was organized hierarchically. Very hierarchically. Cards needed immediately were kept close to the machines. This was known as level 1 cache. Cards that might be useful later were stored farther away. Level 2 cache. And information that probably wouldn't be needed anytime soon was placed in cold storage. Which, in this world, meant a warehouse so distant that it sometimes had its own weather. Latency was not measured in milliseconds. It was measured in how far a forklift had to drive. Training in artificial intelligence required data. A truly unreasonable amount of data. In this world, data did not stream. It arrived. In scheduled shipments. Trains delivered freight cars filled entirely with punch cards. Crates were carefully labeled. Raw text. Mostly correct. Do not question. Before training could begin, the data had to be prepared. This process was known as pre-processing. Thousands of workers sat at long desks, punching individual cards by hand. Each hole mattered. Every typo was permanent. Every misplaced hole became a fact. Mistakes were collected in special bins. These bins were labeled hallucinations. Once prepared, the data entered the training floor. This is where the intelligence was assembled. The training machines were enormous. They filled entire buildings. Belts carried punch cards upward, downward, sideways, and occasionally back the way they came. Each machine represented a layer of the model. A language layer. A reasoning layer. Several layers that nobody fully understood. But everyone agreed were very important. Training ran continuously. Day and night. 4 weeks. When the model made a mistake, it had to be corrected. This process was called backpropagation. Backpropagation was not automatic. It required authorization, paperwork, and occasionally, a union representative. Once approved, massive levers were pulled. Belts reversed direction. Thousands of punch cards were removed, repunched, and reinserted. One hole at a time. Optimization was slow. Painfully slow. But morale remained high. When accuracy reached 62%, there was a celebration. After several months, the model was finally considered adequately trained. It was now ready for its true purpose. Answering questions. Asking a question was known as inference. It began, as all great technological achievements do, with a form. The request was reviewed for clarity, for necessity, and for optimism. Once approved, the question was converted into punch cards. A small, pristine stack. Carefully labeled. User prompt. When this stack entered the system, it triggered everything. Entire departments sprang into action. Cache managers. Routing specialists. Senior forklift operators. Relevant knowledge had to be retrieved from memory. Some information lived close to the model. Other information lived very far away. Occasionally, information was missing. Or mislabeled. Or on fire. Once gathered, the punch cards converged toward the inference engine. This machine evaluated probabilities, weighed meanings, and attempted to decide what you were really asking. Processing time varied. Some questions were answered quickly. Others required patience. Estimated response times were posted on large boards. 4 hours. 6 hours. Eventually, the staff prepared the response chamber. A small glass window. Polished carefully. Thousands gathered. Engineers. Operators. Observers. The system churned. Belts moved. Cards vanished into the machine. And finally, a single punch card emerged. Printed on it, the model's response. It read, "It depends." The crowd erupted. The answer was archived. Carefully. Permanently. Over time, the engineers noticed something. The machines worked. Nobody fully understood why. But the answers were usually correct. The system was enormous. Inefficient. Deeply impractical. Yet, it produced intelligence. Improvements were suggested. Carefully. Quietly. One proposal, in particular, caused concern. What if we reused some of the punch cards? Committees were formed. Studies commissioned. Warehouses audited. Tests showed promise. Slightly faster responses. Fewer cards consumed. But progress was slow. Because change, in this world, was expensive. And so the system remained vast, complicated, strangely effective. To an outsider, it looked absurd. An impossible amount of effort for a single answer. But to the people who built it, it made sense. It was the best tool they had. Because intelligence, it turns out, is not about elegance, or efficiency, or even understanding. It's about results. And about saving time. And in every universe, no matter the tools, time is the most valuable resource there is. Some worlds saved time with silicon. Others, with paper. Different tools. Same goal.